This is an example of heat conduction, and the heat current is given by the heat conductivity times the area times the higher minus lower temperature over the length of the conduction surface. So we can get the conductivity from tables. We find out that for styrofoam, 0.027 watt per meter Kelvin. The area we're given as 0.8 meters squared. There's a high temperature of 30 degrees Celsius minus 0 degrees Celsius over the length of the conducting wall is 0.02 meters, and that will give us about 32.4 watts, which is the same as 32.4 joule per second. That's why it's called a heat current, because it's the amount of heat per unit time. To get the total flow of heat, that's going to be the heat current times the time, and we can use the fact that this will give us also it's equal to the mass times the latent heat of fusion. So to find the mass of the ice, we can say that this is Q, the total heat, over the latent heat of fusion. And now this is going to be HT over L sub F, which is 32.4 joule per second times 3 hours times 3,600 seconds per hour, all over the latent heat of fusion we can find in a table, and it's 3.34 times 10 to the 5th joule per kilogram. And you'll notice that we're left with kilograms after we do this.